Okay, you ready? So the attribute we're going to talk about today, we're going to talk about continuous and discontinuous. So continuous is if you can draw the graph without lifting your pencil up, right? So this is continuous. Can I draw this graph without lifting my pencil up? This is discontinuous. And we have three kinds of discontinuous. We have infinite, and infinite is from an asymptote, so we call it asymptotic also. So infinite and asymptotic, so it's the same word. Yes, so Cabello is an asymptotic child. This right here, it's like we're jumping, right? You have to like jump off of something. So we call this a jump, like the third grader off the desk. That's a jump. And this one, where it's just one single point, it's removable. And these are all at x equal. So the asymptote would be at x equal a. The jump would happen right here at x equal a. And the whole is at x equal a. Whatever the x equals, that's what is causing our discontinuity. So discontinuity gets caused by the vertical asymptotes. Okay, by anything vertical, that's going to cause our discontinuity. So if you look at these 6 right here, can you find the continuous ones? Which are continuous?
2, 4, 5.
Is 5, 2, and 4. For those of us that would like to pass. So what is number 5? And what point is it removable at? What x point? Correct. So it's removable at x equal -3.
Oh, she's gonna die. You gotta give her some water.
Do you need a drink? She's fine. Give her your water. Okay. She can go. She needs to. She don't want to, Cabello. She's fine. Stop talking for her. Okay. What's this one? Jump at what point? X equals -5. All right. So what happens here? It's an infinite, and what's the vertical asymptote? 1? I think it's at 1. So how many asymptotes on number 6?
2.
But which one do we want? Which causes the discontinuity? The vertical, and so it's at which point? 2. So this is going to be either infinite or asymptotic. It's the same thing. What about the whole? That's removable. Is it 4? Thank you. So what causes discontinuity? Horizontal or vertical? Vertical. So these are all x equals. So the last thing we're going to do today is end behavior. And so end behavior means I don't care what's happening in the middle. I just want to know what's happening at the very ends of my graph. Okay? So this is how I'm going to read this. As x approaches infinity, f of x approaches. Okay? So first of all, what I want to fill in x direction, this is negative infinity and this is positive infinity. And in the y direction, this is positive infinity and negative infinity. So f of x is the same as what? Y, right? So what I'm looking at, as x goes to infinity, what is my y variable doing? So this time, as x goes to infinity, what's happening to my y value? It's going to negative infinity, correct? And as my x goes to negative infinity, what is my y value doing? So it's going to positive infinity. So the hardest part of what is you have to write that out every time. So you have to write out as x goes to infinity, f of x goes to. As x goes to negative infinity, f of x goes to. And you just write it all the way across, because you got to do it every time. Who is getting text? It's going away. So if it helps you to label this, label it. So this is infinity for the y's, this is negative infinity for the x's, and negative infinities for the y's. So for the first one, as x goes to infinity, so as my x goes to infinity, what is my y doing? It's increasing to infinity, right? As x goes to negative infinity, what is my y doing? It's also going to positive infinity. So this time, as x goes to infinity, what is my y doing? So this time it's decreasing, so it's negative infinity. As I go to negative infinity for the x's, the y is going negative infinity. So look, when I looked at this, I was looking at the end behavior, which is here. It doesn't matter to me what's happening here at all. It doesn't matter what's happening in the middle, just the end. So here, all the stuff in the middle, it doesn't matter. I just want to know the end behavior. As x goes to infinity, what's y doing? It's increasing. As x goes to negative infinity, what's y doing? It's going to negative infinity. It is easy. So the only thing that's going to change that is if there's an asymptote, and it has to be a horizontal asymptote this time, because we're looking at what's happening at the y value. So as x goes to infinity, what's happening to the y? So as x goes to infinity, what is happening at my y value? It's not going past the asymptote, is it? So what's the value of the asymptote? -1. And if I go the other way, if I go to negative infinity, still, what am I approaching but not crossing? -1. So we have to fill all these in. So the best way to start these is to draw in the asymptotes. So when you draw in the asymptote, you can see what it's going to. So as x goes to infinity, what's y going to? It's not. Infinity would keep going up. It's going to 0. As x goes to negative infinity, what am I approaching? 0. So here's my asymptote here. So as x goes to infinity, y goes to, is it negative 3? 1, 2, 3. And at negative infinity, it also goes to negative 3. As x goes to infinity on this side, I approach 2 and 2. So let's see. The question is, when we do these, are they always the same number? So as x goes to infinity, first of all, I'm going to draw in my horizontal asymptote, which is right here. So as x goes to infinity, I go to negative 2. And on the negative side, I also go to negative 2. What am I going to on both sides here? 0. So draw on the asymptote on the last one, which is here. So as x goes to infinity, what does y go to? Negative 5. And as x goes to a negative infinity, what happens to the y value? It goes to infinity. So they don't always match.